hopefully managed to isolate it. But have a piece like any multiple lens. There's one here, small particle. I know we're very crowded and we're really sorry about this, and we were going to find somewhere else for this meetup. The good news is that Facebook have stepped into the breach, and they've offered for us to hold the meetup there. Their offices in near Euston, opposite Warren Street. So Camilla's here from Facebook today, so can you say hello? So that holds 400 people. So on next month we'll just be able to have as much space for that each week. Thank you very much, Facebook. Where else better? So a couple of things I want to get out of the way. So there's Ryan Florence who wrote React. Oh, that's better. You can probably hear me now. Ryan Florence, who wrote React Router, is running some courses, and he's giving away 2 free tickets to attend an online course, which is 720p streaming, and it's on Friday, the 13th of February. At 4 p.m. because it's obviously in America. So if you want to join that, or if you want a free year subscription to all their videos, which is worth $390 apparently, if you want any of those 5 things, just tweet #LondonReact what you want and why, and we'll just give it to you. Well, he'll give it to you. So thank you very much for that. So we've got 3 talks tonight. From Jof, Gary, and Christian. Jof's going to go first. He's VP Product at timecounts.org.
Yeah, no, it's cool. How do you survive with this many windows open? It's insane.
Benji has like, what was it, 44 tabs.
Yeah, 2 windows.
It's crazy. Yeah, let's do that. Hey, awesome. And you can hear me. Excellent, good. Yes, thanks for the intro. I'm Jof, VP Product and co-founder and front-end developer. And sitting down there with his bandana is Benji, who's our CTO, and he's our everything developer. So what Time Counts is, briefly, it's just a platform for building and managing communities. So because last time there's quite a lot of people here, here's some follow-on links for you. If you want to go to this exact presentation, it's timecounts.github.io/backbone-react. And it's probably worth doing because there's a few slides here with quite a lot of code on them, and sometimes it's quite hard to see. So how did we start off? So December last year, we started off the project, and we built out the app with Backbone. Oh, yeah, not last year. Oh my God, yeah, that would have been really fast, wouldn't it? That would have been pretty impressive. Yeah, 2013. And it's for Backbone MVC. We use Rendr, which is a isomorphic library. We use jQuery, back then, of course, and we use Handelbars. Yeah, and so it didn't take too long for us to discover that actually this wasn't a lot of fun. So, even with the best intentions in the world, we're storing state on the DOM. Obviously, you guys have probably found this. If you do layout changes, maybe for styles or whatever, then you start breaking your jQuery selectors. And so, okay, you can sort of hack around that by having class names with underscores in them and stuff like that. And then, of course, there's the issue of re-rendering views, which I'll come up with in a little bit. And yeah, it's basically a total nightmare. This picture of Squidworth is basically like how I felt every day after 6 months of doing this. I literally, actually, I think my flicky eyes on the right-hand side. So around about sort of June-ish, roughly, we've known about React for a while and been really interested. And we realized, there's perhaps an opportunity to refactor a few things. And we saw React, and it looked absolutely fantastic. But pretty much everyone, bar about Udacity or Khan Academy or someone, was building everything again from scratch. And we thought, okay, React offers a lot of benefits. Should we rebuild from scratch? No. So we had, by that point in time, Yeah, like that, exactly. So by that time, we have roughly 50,000 existing lines of code. We like Backbone and Backbone models and collections in particular, and we required Backbone for the isomorphic framework we're using. So rebuilding is absolutely not an option. So what do we do? Okay, so let's combine them together, we thought. So we started with a plan. Number one is we adopted a policy of all new views in React, every view. And another one was keeping those Backbone models and collections around that we love and needed so much. So sort of like in small print down there, there's actually a bit of a bonus because we're a startup and we move really quickly, the consequence of all new views in React means pretty much anything ends up in React by the end of it because it's all changed anyway. Okay, so here's a warning. This is about Backbone React, and there is hackery ahead. So this definitely is not the correct way of doing it. By correct, you might say Flux. But what it is, it's a really nice way of getting all of that lovely React goodness into your Backbone applications without having to rebuild everything. So here's a really simple example, super simple, and hopefully it will jump out into, excellent, good. So the most basic app you could possibly imagine. So it has this home view here, and I click on this paragraph tag, and it all just changes the numbers. I can add some notes in here. This is all in Backbone, and I can change, and the notes are still there. I'll explain why that's important in a second. And I can press the About, look at the About view, and there we go. So a simple two-page app. So, okay, what's behind that? So, of course, we've got a Backbone router, and I guess some of you guys are familiar with Backbone. So it's a pretty simple router. It's basically removes and adds the views back again depending on the route. The About view, super simple. So you have an underscore template there and a very, very simple render function. And the home view is a little bit more complicated. Again, an underscore template, just a few things you have there. Between that span, you'll notice that's where the, can you see the cursor? Excellent, you can, good. Okay, between that span is where the random number goes, and there's a click event on that paragraph tag, which then runs render. And the render function generates all that stuff. Sounds right? No, it's a bad idea. So one of the consequences I mentioned earlier about running render again is you basically lose, I think that's in the DOM. So remember I was typing in that little text area? Well, if we're running render, bang, it's all gone. So instead we start doing this sort of thing. So what we do now is that new number, we have a method here, new number, that basically uses a jQuery selector to find that span, then generates the random number and then updates it. Well, okay, that looks okay-ish, but actually that's the root of all the madness when it comes to doing a Backbone application. Because before you know it, okay, the designer says, I don't want a span there, I want to stick it somewhere else, or maybe I want a div instead of a span. And then before you know it, you've got convoluted selectors that are now at odds with your layout and all sorts of other things. There are ways around it, but it gets nasty pretty quickly. So let's convert it into React. So router first. How many lines of code do you think it's going to be? Well, not very many at all. So basically the remove stuff, we now test to see whether or not it's a Backbone view. And if it's not, we use react.unmount component node. And the add stuff, if it's a Backbone view, we do the old stuff. If it's a React view, we use React.render. So it couldn't be simpler. As for the views itself, well, we'll pick the home view. That's a little bit more complicated than the other one. And this is a really important step now. So what we do is we stick the random number on state. So in that string there, as part of the template down the bottom, you can see this.state.random number. And instead of, so when we click on the paragraph tag, it has an on-click handler, which is this.new number. And now we set the state. So because we're changing the state, React does all its Reactive goodness and updates it for us. We have a little bit, there's a reason why we've done it like this. We don't actually, a slight segue, but we don't actually use JSX. We use CoffeeScript. And CoffeeScript, by referencing React's DOM property like that, we can actually do some really, really cool stuff that enables us to lay out all of our elements in a way that's kind of similar to Jade. I'm doing a presentation at the Backbone event next week If you guys are there, you'll see a much more elaborate investigation of this. If you're not, I'll just tweet out the link anyway. So what's changed? Random number is now stored on this.state, and there's no fragile jQuery hunt down the tag and change the HTML nonsense. Pretty simple so far? Cool. And if we have a look, perfectly identical React version. Yay. Okay, so that's pretty simple. So let's get to the backbone stuff, the models and collections. So this is where Backbone and React together really shine. So we've developed a mix-in that we're going to run through you in a second that automatically re-renders after Backbone models and collections have changed, so long we do it as we do it on this state. So here we go. This the first bits of the mix-in. So we extend Backbone's own listener and stick it on state. And then we handle React's lifecycle methods. So obviously when we do component div mount, we subscribe to the Backbone objects. When we do unmount, we unsubscribe from them. And our method of for unsubscribing is reasonably simple. What we effectively do is we iterate around all of the props, and whether if they're a Backbone model or a Backbone collection, we then do stop listening or listening to, which is dictated by the flag unsubscribe, to those various different events. So on model, that's change, and on the collection, that's add, remove, reset, sort, etc., etc. And so the callback for all of those methods is this one, which is force update once. So what we don't want to do there is call force update for every single possible change, because that'd be crazy. So we only want to do it once per run loop. There is a caveat there. It's pretty cool. It makes the cascading models and collection changes really efficient. However, the update isn't in real time. So if you do something like you have an input tag where it's maybe like a user's name, and its value is this dot state dot user model dot get name, then you actually end up with a little bit of some shenanigans, because the input is equal to that value, and you start typing in wanting to change it, and React's like, nope, no, it's not the same as that one. So we have like a slight bit of extra code around here. So basically you have an onChange handler. So when you change the content of that input, it then sets the model based on that value and then does a force update. So it's not too much hassle, and you get all of the goodness. Here's a little bit if you want to do handle a sync event on a collection to update dependent collections. You may or may not need that, and if you do, Benji can elaborate later. And to use it, it could not be simpler. Add your Backbone mix-in to your mix-ins array, and stick your model on state. That's it. That really is it. Change a Backbone model property, and everything automatically updates. Happy, happy, joy, joy. Everyone is happy. And this is the stuff that keeps us really happy during the day. It really genuinely does. So let's run in Stimpy if you're sufficiently old. One thing that's kind of a little bit peculiar to us, and it might apply to a couple of you guys, we use Rendr, as I mentioned, and this is a framework that passes data via this props before actually the view is made. So what we have to do there is pass our props onto our state, so that view can look after them. In a note there, since the Backbone mix-in monitors for changes of the state, just to be clear. I won't go into too much detail about this. It is literally what I said, which is moving props to state and subscribing and unsubscribing. If you're interested, ask that guy here, and he will delve into more details, but you're probably not going to need it. But it's here for completeness anyway. One thing that's really key and can go horribly wrong is don't oversubscribe. So only use that Backbone mix-in when you have models on state that you want to listen to changes to, and only use that props mix-in on top-level components. And the reason why is because obviously if we're using force render, you can imagine if you have all your various different components and subviews all listening to all of these changes, it's going to be completely chaos. So almost always, and I think it's fair to say in about 99% of our app, we basically have all of our collections and models on the very top level of view. I think there's like maybe one exception because I
There's cards.
There's a card, yeah. So we've got this one exception where this view just handles ridiculous amounts of stuff that's nothing to do with the top level view, and so that one has the mix-ins. But generally, it's best to be avoided. So that's it, really. So a quick recap. And this is an important one because I was speaking to some guys before about doing React. You don't need to tear everything up and start again. So if this is your own startup, start looking at Reactive Backbone. If it's your CTO or co-workers saying, hey, we don't want to do this, tell them we did it. It's actually not that hard. Where we succeeded, I think, is doing a policy of all new views in React. So we start to kind of infect the rest of the app with React. We've got our backbone mixing, which of course you're welcome to use for auto-subscribing to events. We've got the backbone props mixing if you absolutely need it. And the end result is, of course, easier to maintain code, a lot less of it, and basically me and Benji saying, I love React pretty much every day.
Pretty much every day for
yeah.
7, 8 months.
Yeah, I think we had a couple of breaks. I think we finally got over it now. We're using it.
I said it yesterday.
No, you said it yesterday. There you go. So thanks for all this stuff. We really love React. So just one final side. If you're interested in revolutionizing the industry and you really, really love big, interesting, complex React apps, we are hiring and we'd love it for you to join us. Either way, here's my details and Benji's details, and thank you very much. That's it. Yes, questions now, or okay, yeah, go for it. Questions. Come up here, Benji, since I'm going to be relying on you when someone says something really awesome. Yes, go for it. Oh yeah, sorry.
Typecounts.github.io/backbone-react.
And if you look at our GitHub as well, our repository, we've got the examples both in that slide, but also there as well. You can find all of the content. Yeah. Any more questions?
Yeah. So,
yes.
So if you were hypothetically to rebuild it again from scratch, would you pick Backbone React as an option, or would you perhaps go with something else?
I'm not exactly sure. We haven't looked into it because we don't have time to do so. But yeah, we'd certainly look around. I've looked at things like Backbone Router, React Router looks quite interesting, and various things like that.
Yeah. And I know a few people have basically answered pretty much your question. They've chosen Flux, for instance.
Yeah.
We don't have enough experience for that to kind of give you a brilliant answer, but we probably wouldn't use Backbone. That's my hunch. Yeah. Anything else?
You mentioned that it was isomorphic. What do you use to do the isomorphic? It's probably a big question, big answer. I don't know.
So, so the isomorphism is done by the Airbnb's Rendr, which is it was a proof of concept really, and it started off quite good, but it does have its issues, and they're still working on it a bit. I think it's moved over, and different people are maintaining it now.
Are they using it?
They were using it for their mobile site,
I don't think they do now.
but I don't think they do anymore. And we use it much more heavily than I think they ever did.
Yeah, I think it's fair to say quite a lot of our work, particularly once we started bringing in React, was actually working around that stuff.
Yeah.
So I don't know, it's sort of answers your question as well. When we look at the future of the isomorphic side of our application, I think you were considering splitting out, forking our own version of Rendr, or maybe if we start looking again at Flux and whatnot, we might consider something completely new.
We've got enough monkey patches for it. We've practically got our own version anyway.
yeah, exactly so. Yeah. Cool. Oh, another question. Yep.
You mentioned something about CoffeeScript Jade-like JSX substitute, and you'll be presenting at another backbone conference?
Yeah, it's like Tuesday or Wednesday next week.
Tuesday.
It's London Backbone Meetup. Sorry, Guy, for not remembering the exact name if you see this. But if you follow me on Twitter, I'll actually be, if you aren't able to make it, because I think it's already subscribed, I'll produce another link, and that goes into, as I said, kind of how we produce our views very, very quickly using CoffeeScript. Controversial, maybe, as we've discussed earlier. Good. Excellent. All right, well, thank you very much, everyone. Appreciate that.
Just put my glasses on, I can't see a thing without this. So next up we've got Gary. Just going to hide that. Escape. How do I come out of this? Do you want to use this? Oh, you're using it. Okay, cool. No, not at all. There you go. See, let me get this set up. Just get the hang out of them together.
I have no idea. You might have to help. It's a good start. Right, it's a green one. No, we use Hangouts. And then you can just select other window which you want to share or screen. And that. And then that. Yeah, that should appear. I haven't plugged it in. Oh, that's not really working. That's not quite right. I guess mirroring off and it'll just.
Just refresh.
Yeah.
Also, yeah.
Nice.
You're sharing as well. Just check.
What am I doing now? Hangouts. What am I doing?
Yeah, just go again. Green button.
This guy.
Yeah, select.
Entire screen, yeah. That's what I had on. Is that okay?
Yep.
Fine. Cool. Ready? So yeah, my name is Gary Chambers. I'm a software engineer at Football Radar. And just a quick sort of introduction into who Football Radar are and what we do. Basically, we predict football matches, which massively oversimplifies what we actually do. It's a lot of numbers, like numbers I don't really understand. My role specifically is working on the UIs, I'm a JavaScript engineer. I work and lead the UI engineering kind of side of things. A lot of the data models that go on in the background scare and confuse me, but luckily I've got very, very smart people working with me who can sort of take care of that side. But what it does mean is we're building a lot of interfaces that are to do with data visualization and data capture, and bringing kind of discrete streams of things like odds and goals and all kinds of things to do with football, essentially, and football markets and football betting together into one place. Now, we started using React maybe 8 or 10 months ago, and to be honest, we didn't really know kind of what it could do or what it was for. We just had a few applications that we'd built that really could have benefited from some performance. They were really struggling under the weight of the data that we were working with. We were rendering real-time applications with far more data than the DOM could cope with. We were essentially breaking all the rules of UI development. We were incrementally updating the DOM on every single update, and this kind of meant we had WebSockets that were publishing maybe hundreds and hundreds of events a second, and we were trying to get the DOM to capture every one of those, which obviously was never going to work. And it basically meant for a horrible user experience. So having heard about React, we kind of thought, well, this is supposed to solve that problem for us. So we kind of, learning as we went, we kind of piecemeal put React into our application, trying to plug it into a legacy application that was, frankly, a little bit terrifying to look at. And the result was, it was really nice, but it turned out to be quite unmaintainable. Not the React part, but just kind of the way that we'd implemented it, because we had no idea how the kind of architecture around React was supposed to work. Then more recently, we started looking into RX and reactive programming. Now, just as a quick show of hands, has anyone kind of worked with RX before, or maybe reactive programming languages like Bacon, not languages, but libraries, Bacon, Kafir, Highland, that kind of thing? So we've got a few. It's kind of a model for dealing with streams and data flow. It's a way of thinking about how your data is changing over time. Does anyone use Gulp as a build process? I'm expecting a few more hands here. This isn't necessarily a reactive library, but it is dealing with streams and it is dealing with data flow. It's dealing with, if you imagine you have a Gulp task where you're concatenating or minifying something, you are essentially passing it through a pipeline. And that is kind of a step towards the reactive model that we're working with. Now, I kind of want to introduce RX not necessarily as a concept, but as a library. But it is quite useful to get a handle on the sort of conceptual side. But first, what I'll talk about is what RX specifically gives you. Now, there are sort of analogous concepts in other popular libraries. I mean, Bacon has the idea of event streams, but I want to talk specifically in RX terms, in RX vernacular. So first of all, what it gives you is a data type called an observable. And what an observable is it's like an asynchronous collection. So if you imagine you've got an array or any kind of iterable collection, and you imagine you introduce the concept of the notion of time to that. So instead of a series of values that are available to you all at one time, you have this idea of a collection where the values are yielded over some period of time. And that's essentially what an observable is. It's a way of thinking about events, whether it's DOM events or dispatcher actions, for example, in a Flux application. It's a way of thinking about those as a continuous collection, a stream that has some kind of size and some kind of shape to it. What RX also gives you is a series of functional operators. Now, these will seem very, very familiar if you work with the array extras kind of set of operators. You have things like map, you have things like filter. What it essentially is the link operators, which it's something that Microsoft develops. It's a way to think about collections and kind of compose them to transform the data, and a way to think about how the data changes and transforms as you move through this operation. Now, what RX actually is, stepping back slightly, is a way to think about your application in terms of data. Now, this might be this is probably too high level for what I actually want to talk about, but it is quite useful to think about what you're actually trying to do, what you're actually trying to accomplish, and why RX is such a good fit. Because I personally have felt, sort of, for the last few months working with it, that it's almost the perfect fit for UI development. Especially, I mean, when you think about you're working in the browser, you're working with asynchronous data all the time. You're working with this element of time all the time. So be able to treat that as something that you can sort of not necessarily iterate over, but consider as a collection becomes very powerful. So typically you have two types of data in your application. You have discrete data, which are events, things like a click event would be a discrete event. And you also have continuous data, like a mouse move, where the cursor would move from point A to point B on the page, but it has to cover everything in between. And as a result, you can treat that as a single value that is changing over time. Your coordinates on the page translate over time. Now, pretty much any talk you will watch about RX, and there's been a lot of them come out of Netflix because they love this library, they use it quite a lot, will pretty much first thing talk about how you can implement a drag event in RX. And I desperately want to do something original, but it turns out that's a really good example because it actually captures some of the nature of what RX can allow you to accomplish. Because RX isn't just about creating these observables and observing these events, it's about how you can compose them together to do something really elegant. And one of the things that they particularly love over Netflix is the fact that they basically never have to unbind an event. They pretty much love that. That's pretty much their headline. Whenever they talk about it, is I can bind a mouse down, I can bind my mouse move, and I'm binding my mouse up, but I never have to care about unbinding. I don't clean up after myself. I just say this is when it starts, this is when it ends, and the library takes care of the rest. So maybe I'll just dive a little bit into what the code looks like. That worked, how it's worked. So this is kind of the little segue. I just want to talk about this just before I dive into actually where this fits together with React. Just so you can kind of get an idea of what the code would look like and kind of how these objects work together. So in this example, you are modeling a mouse drag as the composition of 3 streams of events, three observables: mouse downs, mouse moves, and mouse ups. Oh, of course, yeah, sorry. Is that better? Better, worse, better. Is that okay?
Can you turn off flux?
Hmm?
Can you turn off flux?
Oh, of course, yeah. I don't even notice it anymore. Oh, blimey, it's bright. I haven't even, to be honest, I don't even, I get used to it so much now. It's just like I'm sitting there and someone comes to my desk and say, "Why is your screen orange?" I have no idea. Okay, so, right, what was that? Yeah, so you've got these 3 observables, and essentially you're building a drag as a composition of these 3 streams of events, and you're thinking about how the data moves through your application. You're actually declaratively modeling the data flow. And this will become very interesting when I start to talk about Flux, because Flux is essentially a pattern for data flow. As you can see here, what I've essentially said is, okay, with my observable of downs, my collection of mouse downs, for each one that I receive, I'm going to map that to, thanks, G, map that to the observable of mouse moves. So for every time I get a mouse down, I want to observe all the mouse moves. I'm going to observe all the mouse moves until I receive the mouse up event. That's essentially what drag is. The anatomy of a drag is mouse down, move, mouse up again. But I can very declaratively model what that means. Then making use of some of these functional operators, I can basically say, given my event, given my mouse move event, give me an array that contains the x and y coordinate. I then have some other nice things I can do. I can throttle it in some way. Sampling it in this case is just saying every, well, 60 times a second, give me whatever you've just received. And then I can also do things like, okay, given an initial value, then what would it look like after each of these events is processed? And finally, I can then kind of almost iterate. It's the language implies iteration, but it's actually push rather than pull. You're not pulling anything from a collection, it's being pushed to you, but the kind of semantics are the same. And I have that pushed into my update coordinates function, which updates this element on the page. And assuming I have done this correctly, I did this very late last night. Yeah, as you can see, as you move around the page, I'm modeling that as mouse down, mouse moves, and mouse up. And as you can see, I haven't actually had to unbind any events. And as I say, that is pretty much the first example you'll see in any talk about reactive programming in RX. And it seems to be quite a good example, but it's really not interesting in terms of React and Flux. So I'm going to move quickly on. Okay, so Flux. I take it most people, when they're building with React, now think about it in terms of Flux. I mean, Flux has become a kind of de facto standard for how you're supposed to build a React application. I mean, as Jof said, it's supposedly the right way. It's a way, and I think Backbone is a particularly good alternative. But I'm afraid I fall into the camp of people who've just kind of taken an application and just gone, yeah, throw that away. Let's start again. We were in a slightly fortunate position in the code that we had to start with wasn't really worth salvaging. So it gave us an opportunity to think, okay, how can we rebuild this, and how can we build it in a different way? I've worked with Flux, and I really like what it's trying to achieve. I really like the fact that it's thinking about it in terms of unidirectional data flow, and it's thinking about it in terms of very sort of high predictability, really. You're thinking about how data moves through your application. You're thinking about data flow. So the Flux kind of design pattern, and it is a design pattern, it's not a framework, even though there are so many implementations that are kind of become standard that it could almost be a framework. The design pattern is very, very narrowly scoped. It says it's unidirectional data flow, great, but it's also these 3 things. Well, 4 if you count the React views as well. It's dispatchers, it's actions or action creators, I forget, they changed the terminology slightly now, and stores. And it's the relationship between these 3 different kinds of component, these 3 different kinds of module. And it's a mostly declarative model for thinking about data flow through your application. I say mostly declarative. I mean, it basically is declarative, but there's this kind of peculiarities to it. Like you have a singleton dispatcher, and you're registering all your stores to it, and all of your stores receive all of the actions, and then must make some kind of imperative calls about whether they care about a particular action type. And some implementations kind of hide that away better than others. Some allow you to kind of treat the action type as like a top level parameter and just say, only show me, only call this function if you get this particular type of action. But ultimately, it's a slightly peculiar model. And I know that the single dispatcher model was designed for predictability, but I've always felt that's a little bit uncomfortable. So stepping away from Flux a little bit, I thought, and having looked at RX, I thought there's a bit of a parallel here, because both are trying to achieve data flow, both are trying to achieve a way of thinking about data moving through your application and rendering a very, very predictable end result. So the question really is, should you use Flux or should you use RX? And, well, both, to be honest, because, well, Flux being a design pattern, you can implement Flux in RX. In fact, there are some implementations of Flux that use RX, like RX Flux. But what I actually want to do is kind of think about Flux more conceptually. Think about not can we, to the letter, implement this design pattern that has dispatchers, has action creators, and has stores, but how can we use RX to its full potential? How can we let it shine, really? And that's kind of the model we've approached at Football Radar and how we've kind of started building our applications. As I say, RX isn't strictly Flux, but it's Flux-ish. It has some objects and data types that allow you to implement a similar sort of thing. Both encourage unidirectional data flow. Data moves from, in the RX world, it moves from one observer into another observer. In Flux, it's a case of a binding between dispatchers and stores, events between stores and views. It's a way of kind of encapsulating that observer pattern. They're both basically following the observer pattern, which is why there's such broad similarities. The difference really is the way that those modules interact with one another. In Flux, it's very loosely coupled, so you kind of have this hit and hope approach to events where the dispatcher will receive an action and it will just propagate that outwards. And then it's up to the stores to decide whether they want to care about it. And then stores will update themselves and they'll emit this event, and it's up to views to decide whether they care about being updated. And as such, there's kind of this very, very loose contract between the different parts of your application. Whereas with RX, and as I'll come to demonstrate, you use composition to basically say, given a new value for my dispatcher, and given these operations over that data, update this store, and that store, given some new value, updates this view. And it's a very, very tight, explicit contract. And it seems like tight coupling at first, but actually what it is a way to very declaratively style your application and the architecture of your application. Finally, some code. What I thought I'd do is just talk about RX in Flux terms and just try and draw some parallels, just so you can kind of understand what RX allows you to do. I mean, we do tend to think of, when we're writing applications, we tend to think of RX in Flux terms, but with a few variations. It's just, it makes it easier to talk about. So first of all, with a dispatcher, you have this subject constructor, this subject data type. What a subject is, it is an observable, but it's an observable over which you have control of both ends of the pipe. So if you imagine when I showed the mouse drag example, I was dealing with 3 specific types of observable, and in those, I didn't really control what went into them. I only cared about what came out the other end. What went into them was kind of abstracted away from me, and it was just listen for this event, and then anytime that event fires, push something into it. I didn't manually have to push those events into my observable. What a subject is a slightly lower level construction that says, I've got this pipe, it's a very, very sort of generic pipe, and I can push values in and I can pull values out the other end, but asynchronously. So instead of thinking of the dispatcher as an event bus, I'm thinking of it as a collection over time. The store. Now, store is actually very similar to a dispatcher in that sense. It's listening for values. Values are coming into your store, and values are coming out the other end of your store into your views. The only real difference is a store is retaining its latest value. It's retaining, I mean, yes, you might operate over that value. The value itself might be more complicated than what goes through your dispatcher, which is a single, very simple action. But ultimately, it's a pipe which retains an idea of state. If you've worked with Bacon, then you might understand this as a property rather than as a subject. But it's the same sort of thing. It's the idea of a value that changes over time. Then we have actions. And this is where I can really sort of demonstrate the strength of the subject or the dispatcher that I'm using in kind of RX terms, in that I am, rather than my mouse drag event, rather than my mouse down, I'm not relying on some kind of abstraction to push data into my observable. I am pushing data into my pipe. And then this is the actual interesting bit. Those are just kind of how we can translate flux or RX into flux. This is actually the real strength of RX. This is where we're very declaratively saying, given my dispatcher, given some kind of action, if I map over a value that comes through my dispatcher, where I filter it and I map over it, and then I push it into my store, I can create this explicit contract between the two parts of my application, and then propagate that back into my views again. Unlike, I kind of wish I'd had some Flux code to show side by side, but with the Flux model, you'd have your dispatcher, and you'd have some call to register store or something, and you'd bind the store to it, and inside the store you'd have some kind of handler, and the handler would say, if action type is update foo, then do this, and then it would emit a change event, say, and then somewhere in your store, no, sorry, in your view, you would listen for that particular change event, and you would just call set state, or you would do it at the top level and call react.render. But what the difference is, you have to make all these fairly imperative steps along the way, where you're saying, given this kind of event, I now have to make a decision about what I want to do with that event. Whereas here, you're using composition, and you're using kind of a declarative model to say, this is the pipe that I've created for my data. And now all I have to do is push data in at one end, and I know exactly what's going to come out of the other. Obviously, it's a little more complicated than that. You're never going to be in a situation where you have just one store in your application. I mean, if you do, it's probably either doing too much or your application is a little bit simplistic. Typically, as your application grows in scope, you're going to be adding new stores, different types of stores, different contexts of data. And one of the nicest things about RX is it gives you the power to combine these, to merge these in some sort of way. Depending on what kind of data you have and depending on what you want to do with it, you can use a very compositional model to think about data as this kind of mapping over all of the whole world of your data and bringing it together. Now this combine latest is probably the operator I use the most, and it's a really, really nice. I'm going to explain it very, very quickly because I just love how simple this is. Basically, given these stores and these stores being observable, so they will yield values. Anytime any one of them yields a new value, give me the latest value that you've received for all of the stores. So it's basically a way of saying, I have all of these, and I want to combine them into a single observable that yields a combination of all the values every time any one of them does something. And that's really nice. It's a really nice way to just bring all your stores together and create this array, this object that you can just pass into your render loop. Alternatively, you might have some stores that have very similar data types, but happen to be, you want to separate them out for reasons of context or whatever, but you actually want to merge them into a single stream. So rather than having this idea of two streams that you merge and you map over and you turn into an array of output, you're actually merging them into a single pipe. And maybe that could be useful, I don't know. I mean, these are just two examples of how you can use composition to bring your kind of stores together. Then there's also something else that I demonstrated in the mouse drag event, and something of the mouse drag example, and something that we use quite frequently is thinking about how we can make our streams less chatty. Now, for the longest time, when I was building applications with React, I would come up with really, really hacky workarounds or really kind of inefficient ways to manage chattiness of my data and to manage the render loop. I know React is really efficient. It's got this brilliant diffing algorithm, and it can really, really improve the performance of your application. But sometimes you don't want to give too much data to React to start with, because the diffing is, while not as expensive as a DOM update and a repaint, is more expensive than doing nothing at all. And this is something we found quite quickly with some of the real-time applications that we're building at Football Radar, because they are dealing with so much data and they're dealing with really chatty streams. We don't even want to get to the point where we're having to do the diffing algorithm. We know that there'll be another event coming along like hundreds of times a second. So as a result, we want to either debounce it or we want to sample it in a way that means that we still update quickly enough to seem fluid to the end user, but we're not actually trying to get the browser to do too much work. I'm going to make a little aside here, just to talk about some of the things we've been using in combination with this pattern with React. Now, I pretty much, and this is quite opinionated, and I tend to feel that people prefer to use imperative calls like set state and replace state actually inside the views to update the views. I pretty much always just use React Render from the top. The first time I looked at that and thought that could never work, because obviously that's going to re-render the whole app and be really expensive. But actually, if you pass the same component into React Render, and I apologize if you already know this, but if you pass the same component into React Render twice, the second time it will just do a diff. It won't actually re-render the whole thing. And that's super nice if you just want to treat React as this pure render layer, this pure render function. You don't have to think about it in terms of, oh, and now I've got to couple my event to this particular component and then call set state. That's a lot of imperative calls. In this model, we don't make no imperative calls. We make one imperative call. We make an imperative call to React.render. We're saying at this point, that's what I want you to do. But rather than doing that instead of everywhere in my application saying, okay, this component needs to be updated, and this component needs to be updated, so I'm going to call set state everywhere. I found that very dirty, to be honest, and I found that quite hard to reason about, and quite hard to test, in fact, because I like to be able to just take the React components out and just test them in isolation, and then sort of bring them together with the data. So that's just a reason why you might have seen React Render in an earlier example, and I staunchly stand behind that, to be honest. I've also started using this thing, which you shouldn't, I shouldn't, no one should, because it's not documented, but it's quite nice. There's this idea of context. I saw this blog post sort of come out of the wild somewhere a few weeks ago. You may have seen it, I don't know. Basically talking about this particular function. And what with context does is, instead of declaratively passing properties into your component, it just creates like an implied context around your application. So at any point in your DOM tree, or sorry, inside your React component tree, you can just say, oh, hey, I'm interested in this context. I'm interested in, let's say, for example, your context is passing in a dispatcher. You say, well, in this component, I'm interested in the dispatcher. I'm interested in dispatching an action, or something like that. And you just say, oh, can I have the context, please? Can I have the context for this render? And it just passes you this new this.context kind of object, which contains your dispatcher or whatever you passed in. Now, I believe the whole idea of context in React is going to stick around, but it's going to change, and the way that it's going to be kind of implemented is going to change. I think that particular method is going to be, has been deprecated and will be removed. So don't use it, but use it because it's really nice. Like, I'll be very sad when that's taken away. If that gets taken away and replaced with something much worse, I'll be very, very upset. So now, I was going to build an example, a demo that made use of football data, and it was all about football stats. And then I realized that that's actually not very interested unless you're interested in staring at a page full of numbers. So what I've done is been massively cliche, and I've re-implemented this guy to do MVC using the approach that we have. Now, I'll open the link, but you all know what you're going to get at the other end. I think I'm going to open the link. Is it there? Have I done it? There it is. Big surprise. It's to do MVC. I'll prove that it works, so it's like, yeah, it works. So that's enough of that. You don't. Has anyone not seen to do MVC before, by the way? Because I will bring it back if not. Brilliant. So I don't have to show that again. So I implemented that because I thought it's a really accessible way to kind of introduce this approach. The code is available on our GitHub account. Dive into it, criticize it, abuse it. I don't, just do whatever you want to it. It's not a perfect model necessarily, but it's kind of an indication of where we're taking our application design. And I quite like it. It's quite declarative. And I'll show you kind of a snippet from it. I'm aware I haven't really touched on everything that we're doing, but I'm trying to sort of pick out kind of the interesting parts. I haven't really talked about React specifically, but this I find is a really good model for working with React. So what I really want to focus on is what we're doing on the Flux side of things, if you like. And this actually, it's not just me grabbing a whole bunch of stuff and putting it into one kind of blob of code. This actually all does live in one file, and that's probably a terrible idea too. But it's a really nice way to demonstrate the composition that we're working with. So as I've said before, you've got this idea of behavior subjects, this idea of observables that have a current value, and we're using that as our store. So you've got this guy up here, your to-do store. And I've just initialized that with a to-do, but you can imagine that might be empty. That might actually, there might be some clever operator that you use that actually pushes that into local storage. I don't know. That again is very possible. You then have this idea of a dispatcher, which is your open-ended, your two-ended pipe that you're pushing actions through. In this case, rather than the Flux model of having a singleton dispatcher, which everything talks to, I've scoped it right down to just a dispatcher for the to-dos. And in our to-do MVC example, we have multiple types of action. We've got add, remove, toggle, edit, things. So it's a nice way to just encapsulate things that are only interesting to to-do tasks. Then I've modeled the data flow. The data flow is probably the most interesting part, I say again, of this whole thing. And this is kind of what this whole talk is about. It's about data flow. It's about how you can think about your application in terms of how the data is moving through when you're writing the code. So in this case, I am taking to-do actions, and if they happen to be a create action in this case, I will then map it through this function. So this map is a higher order function. It takes this function, and it, in this case, uses React's immutability helper, which also really nice. Use it if you're not, or use something more powerful like immutable.js. And it returns the new kind of shape of the world. Given this value that I've received, given this action, what does my state look like? It then returns that and then calls for each over, well actually that's a typo. It should be to do store, but you get the idea. Now what's clever about this is because for each in Rx world doesn't just take a function like you'd expect in with an array, it also can take an observer or an observable. In this case, a subject is both an observer, i.e. you push in, and an observable, things are pushed out. You can pass your store directly into this construct, and the data flows from one into the other. And as I demonstrated before, the same thing applies when you're rendering. You take the store, you call for each on your store, and you pass in some kind of render function, and data travels from your store into your render function and updates the state of the UI. Probably haven't covered anywhere near as much as I could have done. It's a very rich subject, and I'm sure Christian, when he comes to talk about Elm, will be talking about it in a lot more detail than maybe I've covered. But it's really interesting, and if you're interested at all in reactive programming, then I really recommend you just dig into it. Whether you pick Bacon or pick whatever RX, just try it, because it's a really nice way of thinking about applications in terms of data. Thanks. Are there any questions? One question. Go.
How does your backend work? Does it constantly keep pushing events to your front end?
Are you talking? The question was, how does our backend work with related to our front end? Are you talking about kind of the server-side code and I'm like with one of our applications, we've got just a WebSocket that's pushing data, and you could actually model the whole WebSocket listener as an observable. You could do something like observable from event WebSocket message, and then your messages come in directly into an observable that you map over, and you just then create and compose new observables from that data and just pass those around your application. Does that sort of answer your question? Nice. Yes.
Why did you choose RxJS?
Why did we choose instead of one of the other reactive libraries? The reason we chose RxJS, well, there's a few reasons. The first is, it's the first one I tried out, which is actually, there's a lot to be said for that. I mean, if you try a library and you like it, it's very hard to then pick up something else. I have tried Bacon, I must admit. I have tried Kefir, which is a slightly smaller project, which is quite nice. It's kind of halfway between Rx and Bacon. I've tried Highland, I think, is another one. And they're all fairly equivalent. The thing I really like about Rx, though, is it seems to be closer to a standards track. It's not actually on a standards track, but it's got a lot of momentum behind it, a lot of inertia behind it, which kind of means that a lot of these ideas, this particular observable construct, we might see something equivalent into the browsers at some point. I think some of the people working on Rx are actually on TC39 committee, so I think there's a good chance that some of the ideas might make it into the language anyway. So, not to mention that Rx is also available not only in JavaScript, but it's a kind of polyglot library. It's available. I think it was originally Rx Java. I forget which one came first. But there's also Rx Scala, Rx Pi, Ruby. There's a Ruby one that's just come out. So there's a whole bunch of different. It's the same semantics, exactly the same API, but it's in a whole bunch of different languages. So if you're working with a kind of cross-discipline team, then it's quite a nice way to communicate because everybody's kind of thinking about it in the same terms. Not yet. That's a purely theoretical argument for using it. I would love for us to be doing so, but we've only really been using it in the front end for a few months now, and it seems to make a lot of sense in the front end because it's a very async environment anyway, and that's really what these libraries are all about. It's about kind of encapsulating async and sort of taming async. But I can see a lot of room for it in other environments too. Yes.
So you're using for each to pipe the sequences together.
Yes.
So at some point you must be subscribing and then having the bridge into the DOM. How is that?
I have a slide for that. We are using exactly the same. Oh, where is it gone? Using exactly the same approach for piping into the DOM. I think it was on this slide here. Sorry, I might have breezed past it too quickly. This is really the.
Okay.
Maybe I shouldn't have put it at the bottom. This is exactly the same construction. It's a very compositional, very declarative model because it's saying for each thing that comes from my store, for each new value that appears in my store, pass it to this render function, and the render takes that as props and just passes it directly into my component.
And you're saying that because it's the same object, it does the diff, so it's not.
It does the diff. That caught me out the first time too, but actually that's such a nice approach. I mean, if you like set state and you like having that granular control over your components actually inside the components, there's no reason why you can't use this approach. And in fact, like I said before, there's plenty of Flux libraries out there that leverage Rx or Bacon or whatever and do just that. But I quite like, just personally, this is quite an opinionated thing, but I quite like, I also haven't included a mount point, but I also quite like the fact that you can treat React as this purely functional layer. But then that's just personal preference.
We've been able to throw away jQuery. You still have to.
We don't use any jQuery at all. No.
Where this code lives in terms of usually this code lives in the store in a classical Flux, so it's kind of your business.
Where does the question is? Where does our business logic live? I think is that right?
Yeah.
We kind of, I mean, we still have the idea of stores, and as I said before, the code I showed for to do MVC, that does actually live all in one file. We have this idea of services. We haven't really settled on a nice structure. Like, it almost seems like there's no point breaking this up into different files because that's not really a separation of concerns as such. It's just a separation of lines of code. It's the same reason that you now see we're seeing JSX inside React components. I mean, the argument they made for that it wasn't a separation of concerns, it was a separation of technologies. And I think the same sort of thing applies because this is a composition. Because we're basically saying, I have this observable, and when you combine the two together, having translated the values over this operator, I get some output. You can kind of treat them as one kind of homogeneous thing. And obviously, then you'll end up potentially with really big files, and at that point, you might want to think about how you could break these off into, like, for example, this action could live somewhere else. The store could live somewhere in its own right, but you have this very tight relationship between the dispatcher and the store due to this data flow. And I don't think that's a bad thing. I mean, I've made that sound like tight coupling, but actually it's just composition. It's just a different way of thinking about this relationship. So yeah, generally all currently living in one file, whether rightly or wrongly. Yes.
Hey, so what you've demonstrated looks very elegant. Are there any interactions in your app that have been awkward to model this way?
Yes, and actually the demo I was going to write turned out to be not. It turned out to be awkward at like 11:30 at night when I was panicking. It probably would be slightly awkward anyway, and it's when you're thinking about lots of kinds of data that you're trying to reduce essentially into one object, and you've got these really kind of separated data streams. We had like the example I was going to build was a really rubbish predictive model for football matches. It was going to be some football data coming in, generating some probability distributions, and then outputting some like results. And I didn't have access to the really nice data that we use in the back end because apparently I wasn't allowed to use it. I got told off. So I just went and got some results and it turned out that it got slightly hard to model because I was finding it really hard to think about. Like I wanted to to build a probability distribution, which is a lot of maths I don't really understand anyway. But I think it's more that there's a bit of a learning curve, really. I'm still kind of really simple things like UI interactions are quite easy to model. Really complex interactions between data probably are quite easy to model after some time, after some experience. I think the real thing, my real takeaway is, if you're going to use it, stick with it because it is getting easier. Every time I have to solve a problem, I solve it once, and then it's just like second nature after that. But yes, they're kind of. Yeah, but I think the learning curve is what I take away from that, really. Anyone else? Yes.
Do you think there is any space for mixing what we heard from the previous talk and using background models that look like a bit of a different approach to using React, but in some way I think there might be a space for bringing the two together. What's your opinion?
Yes, actually, because, well, very simply, both RX and Backbone implement the observer pattern. So essentially that is what we're talking about, is how you can observe one thing in another thing. If you took Backbone out of, and I mean the approach that Jof has and the approach that we've had using Backbone, they're fairly the same. I mean that is a very well understood way of working with Backbone and working with React. But if you were to take Backbone like directly out of the components and not think about it as a mixer, not think about it as subscribing to events, but actually take it out and move it into kind of this land, you can just you could wrap your Backbone models, you could wrap your Backbone collections in observable and treat them as these sort of compositional units almost. So you can, I mean, the whole point of RX is to be able to wrap other observers. It's a way of taking some series of discrete events or discrete data or continuous data or whatever your data looks like and turning it into something that you can reason about as a collection. So you could absolutely do the same thing with Backbone, yeah. Yes?
Can I add a philosophical comment to that?
Of course.
Okay,
I might not be able to answer.
Like whenever you make a choice, like you choose a library that has some strong points and it has some weaknesses. When you start combining stuff, then you get the weaknesses of both libraries. So you always have to consider that when you choose.
Yeah, actually, Kristen probably made it slightly more succinct than I could, but yes, that's essentially. I mean, there are trade-offs, but the two patterns are very closely related anyway. It's just a different way of thinking about data and thinking about data flow specifically. Yes.
I got slightly confused by the add-on, the mutable add-on thing, which I think.
This way.
I'm assuming that's also a typo. So that you're getting them to actually to do store.value, is that right?
Yes, it should. I renamed the first one because I thought let's make vocabulary we're all familiar with, and then I just totally forgot to just update the rest. So if you see to do state, that's to do store. Brilliant. Thank you. No, sure. No. If there's anything like about the code at all that's that anyone's not clear on, I'm happy to try and clarify it, because I took the code that we had and I just plucked like a few bits out of it, and obviously didn't rename things properly. So like it's not the full file. Like if you go onto that GitHub project, and the link, I'll publish these slides later on Twitter anyway. But if you do want to go on to, where is it? It's up here. If you want to go to that link, you'll see all of this, the full version really, and hopefully that will at least give you an impression of kind of how you build a slightly more full-featured app. Thanks. Great. Thank you.
That's great. Thank you very much.
Yeah, Brian, a little bit.
No, don't be deaf. It's fine. This article by Chris Cowell, who wrote Q, talks about reactive programming is actually really, really, really good. Have you seen it? Have you read it?
Christian, that was the article I talked about. Yeah.
Have you read it?
I read. Yeah, I have read it.
It's a long.
It's long, and I kind of faded in and out towards the end, but
it's really good.
Yes, I mean actually, just that first bit where it says, okay, so you've got the idea of spatial and temporal, and you've got the idea of single values and multiple values. Yeah. I just suddenly clicked. So that's
I think we need a break for 5 minutes. We get up there and snacks. We need to. I need 10 minutes.
Using multiple locations, so you can kind Great, thank you very much. This is Christian from
Biletto.
I'm going to talk about functional reactive programming in now.
I'll just wait until it's a bit quieter. So, my name is Christian. This weekend I figured out it was actually this week that I had the talk. I made the classical mistake of off by one. Apparently week numbers are not index 0. So I threw something together, and it's pretty interesting because I can kind of build on top of what Gary talked about. At Biletto, we are actually using Backbone some places, and we also went through the process of extracting the views from Backbone and turning them into React. So we are going some different places. So actually, I wanted to talk about like the differences between different kinds of functional reactive programming. It's quite heavy, so I'm not sure how interesting that is. So I created like a lot of different approaches of where we could take this and see how it goes. So we can be either kind of theoretical, or we can be like more in code. Like how many know Elm? Only a couple. So it might be very interesting to actually see some Elm code as well, and not just be super theoretical. I want to start off telling like why I'm kind of interested in the theory behind this stuff as well. It's because isomorphic applications and the virtual DOM thing made me realize that the way that we work today is really inefficient. Like we are duplicating a lot of stuff. There's a lot of stuff on the client side that could be on the server side and should only live there. So you should just be able to specify your applications declaratively on the server, and it will be sent down. Everything should be taken care of you. So it's something I'm really interested in, and I'm super excited about it, and that's why I'm looking at different approaches on how we can accomplish this. Okay, so why did I want to talk about Elm? Elm is actually, no, let me move that up. Oh. So Elm is a functional programming language, and it's a creator, Evan, and I don't dare to pronounce his surname. He was originally a server guy as well, and he started working on the client side, and he was thinking like, why is this so bad? Like, why is this so hard to do? Like, even today, it's almost impossible to vertical center something in the browser. Like, why is that? Doesn't make sense. So he ventured forth and tried to rethink like the way that we develop and how we could approach this differently. And Elm is a result of that. So if you have been in the React.js space, you kind of know that immutability is a nice thing to have. And that's, I saw Gary using it as well, the weird add-on he used from React, and I also agree with him that you should use it if you can. It makes it a lot easier for you to think about what you're doing. Another aspect of this immutability is actually speed. Like it's really essential to achieve the speed that you can get writing something declaratively and not waste computations. Like you don't need to recomputate everything. And that's also a part about functional languages. In a pure functional language, you know, because of referential transparency, that's a property. When you give a function some value, the output will always be the same. Like it would never change. Because you know that fact that the function won't change, if it doesn't change on a re-render, then there's no need for it to recomputate anything. So it's kind of like caching a function, and it's called memoization. So that's like another goal, another like win of doing it this way is you can get a lot of speed. And the last point that's really important is Elm-HTML. Elm-HTML is actually based on something called Virtual DOM, and Virtual DOM is made by some of the guys from Airbnb, and they based that on React.js DOM. So there's this connection between like the stuff that the Facebook guys are doing. It's really interesting, and it spawns all these different kinds of solutions, and like building on top of this, like improving our workflow, which I really like because I don't want to do too much work. So why FRP? FRP has actually been existing for a long time. Like there has been languages from the 1980s. One of them was called Lucid, Estrel, and can't remember the last one. So it's actually an ongoing research project. So from one of Evan's papers, I realized that someone showed that graphical user interfaces are naturally concurrent. Why is that actually interesting? That's interesting because FRP is a technique in order to model concurrency. But there also exist other ways of modeling concurrency. So there's like different approaches to solve that. And I feel that people need to know what's going on, like look out there and not just follow the latest hype. Just think about it, like whenever you make a choice, whenever you choose something, why did I choose that? Why does it help me to solve this particular problem? So this is actually a really important aspect, because if we look ahead, like if we look at other camps, if we look to the closure guys and the closure script guys, they also get benefits from this immutability, and they are going with a different approach. It's called the communicating sequential process, CSP, which is also like a concurrent model. And that's also very interesting. I don't know that much about it, but it's something like the next stuff that I want to go into, because I want to know like which is the best fit for what I'm trying to accomplish, and that is to make good user interfaces. So I really like a lot of the stuff that the closure guys are doing. So especially Rick Hickey, he made me realize a lot of interesting stuff in the way that I program. And also the power of values, right? So in order to get to that world that I dream of, where I can just declare my app on the server, for instance, and get pushed down to the client, saving me a lot of overhead, I think it can be said something like about values. So he has a talk that's called the Values of Values, and I really think that you should watch it. So I put some of his point up, or some of his key points up about the properties of values, and that is they can be shared freely. Like if you send off some value somewhere, you don't have to care about it anymore. Like you have sent all the information you need about the system. For instance, if you're sending a primary key, what have you actually told the consumer of that key? You haven't really told him anything, because he first knows what that value would be when you look it up in the database. And that's a place, and that value can change. Values are really stable, so the benefits of having something simple as values is that you can be sure, right? The referential transparency. I put this value in, I do some transformation, I get a value out, and if I put the same value in, I will always get the same value out. And a thing that I recently discovered is that programming this way, like thinking about values, not thinking about my app, but thinking on a value basis, like what does this mean? What is this value? If I have the value 3, I can like display that in any way I want. I can display it as a numeral 3. I can display it as a banana. As long as I have the value, I have a lot of power. I can decide later on what I want to do with that value. And again, like you can pull out a simple function. You can test it completely isolated. You will know it works. And then the thing about a really big thing about functional programming is composing stuff. So the power that Gary showed about RxJS is that you take some streams and then you combine them, meaning something else, right? So you can kind of this language to talk about your application that is not imperative in a way, because you know like what is the state of my application at a given point in time. You can see that from your code, which makes it much easier for us as humans to understand what's going on in our applications. And so also that the functions are the best interface.
I have a kind of an example of that. I want to show you first. So this is actually some Elm code, and it's also a lot of other. Elm is the compiler in Elm is written in Haskell, but there's this family of languages called ML, which stands for meta languages, and they kind of all have some similar syntax similar to this. So what do I mean by interfaces? If you look at line 5, you can see this is a description. So it says 12 divided by, and the colon is read as has type, or type of. So it's an end-to-end. So this represents a function that takes some integer and returns some integer. But this is actually wrong, right? Because this can break. I'm lying right now. If I give this function a 0, then it will break. I will get an exception and my program will die, which is really, really bad. So what can we do in order to prevent this from happening? Like we can change the input value. We can constrain the input. Instead of saying from all integers to all integers, we say like every non-zero integer. That will fix the problem. We can also change the output, saying something like maybe. So have anyone seen something like maybe or option or either like in functional reactive? Not that many. So I will try to explain maybe. Maybe is a data type. Or yeah, maybe it's a type, and it has two things. It can be just a, oh, I'm missing a, or it can be nothing. Okay, so a thing that can trip people up, and it tripped me up as well, is that from my side, for you guys, the left-hand side, is that's the type, and in order to get something of that type, you use the data constructors on the left. So by specifying this, you can see the actual implementation of it. Is that okay? If the value I pass in is 0, then I will return nothing because it doesn't make sense. Like I can't make a computation like that. But if it is something, then I just divide 12 by that value and return that. But then it's wrapped in something called adjust, and it's kind of a. Do you have a question?
I have just a question. Because there's only few values you can have as an input for this one, like 1, 2, 3, 4, 6, and 12. Because any other value will not produce an integer.
Oh, that's true. This is actually an example for Scott Wilkinson. I think he do some F# videos, which I also recommend. But the idea is behind totality is like whenever you model something, you try to think about it like. Instead of thinking like everything, you can take everything and go to anything, then try to limit the space that you're working with because it's easier to know what's going to happen. In UIs, for instance, I like to think about it like, to backtrack a bit actually, Elm is static, so you always know what you have, like you know what can happen in the system, and when it's static, then you get this property. It's a nice property that you know that only these things can happen. Whereas if it's open and it's not static, then you don't really know what can happen. You don't know what can going on. So that's kind of comparing infinite to a fixed number of values, and that's kind of a big difference. So it's impossible for us to talk about that. But does this make sense in any way, or does someone else have some questions on this? Okay, try to continue. So the interface is also could be seen as like that thing, and a function can be a type as well. So I have like a slide where I will have so this is also valid Elm code. So this is I'm showing off types and that you can use that. So a thing that I really, really like and miss in a lot of programming languages is this thing called union type. Like a lot of times when we program, we just use a map. Like it's nice, it's simple, and it's easy. So we use a map, and map has X, Y, Z. But then a new requirement comes in, and we just add another value to that map. And a new requirement comes in, and we add another value to that map. So suddenly we have a map or an object with 6 different values, and all of those values might be nil, for instance. So
a map is modeling something that I will call AND. An AND basically means that it's a product type, and a product type means that you multiply the values with the times that you have. So whereas a sum type, we are saying we have a type suite, and the value of suite can only be one of these four. Like it cannot have any other value. And by doing that, you are limiting what is happening in a given context. So instead of you're passing something like a map around, giving a delivery type, it could be mail, like snail mail. It could be email. It could be something like it could be a pickup point. Then you have a map with 3 options, and sometimes some of them are nil, and other times it's something else. And you have to check that object every time. Whereas if you know like it can only be one of these values, you check it, you know what value it is, and you run the proper code. So this is so an entire card game can be modeled in Elm or in functional programming language, for instance, as types. And a type alias card is a union type. Oh, sorry, that's a type alias is just saying like it's the record syntax of Elm. So you can think about this as an object, like a normal JavaScript object, and we are saying that that object has a suite key and that has the type of suite. So we know that we have an object, and that value can only be in this form. And we can also emulate the player by using the stuff that we already defined. So again, we are building up from simpler things to more advanced things, giving this nice abstraction of composing things. And the cool tip about like that, it's actually also interfaces, because we can also describe functions in this way. So we can give a type called deal, which describes the function that takes a deck and returns a pair. You could see that as an array in JavaScript of 2 values, where the first value is deck and the second value is card. So the reason I'm showing you this is just to try to give you an idea like what else is out there, and how you could maybe incorporate that in your normal workflow, describing stuff. And also another thing about values is really, really nice. It's that they aggregate to other values. There's a picture that I would like to show from Hadoop. So like the first part of it is something that doesn't combine, and then we map it to turn that into a value, and then because it's a value, we can combine them, reduce them. So I think there's a really good explanation of the value of values being able to aggregate.
Can you share it, please?
This one?
Yeah,
sure.
It might be really useful to explain my previous.
So if you want to get more technical and want to know more about this stuff, then look into something called monoids, which is describing the property about stuff that can be combined. And a monoid is basically just saying like you have a thing, it's associative, it has an entity value, and I will actually have to write that because it's easier. So let's say so plus is actually a monoid because it's a binary operation. It's an identity element and it's associative. So 1 + 1 = 2. Let's see like that. Oh, fuck that. Sorry. And the entity element is 0. So this gives the value itself. And if we do it the other way around, and still 1. And the associative property is that it doesn't matter if you combine numbers like this, or if you combine numbers like so. And it's an interesting topic as well. And like whenever if people want to talk about some more technical stuff later, then please come to me. Like I love discussing this stuff. Okay. Yeah, so I will actually show you. Yesterday evening, I built like a small example case in Elm, and I was trying to be original. So we actually went with something other than the to-do MVC. So I tried to describe a simple music player where you get the normal You can press them left and right as moving up and down. If you go out of bounds, it disappears. You can press play again, and you can use these keys as well. And this is a simple example. And another nice thing about this very original piece of program is that it's colleagues at my workplace who actually submitted the mock data. So that's a nice thing about that. So yeah, let's see. This is the program that you just saw. And to give you like a very, very basic idea of why it's so nice is that you can think in quite simple terms. Like you start whenever you're building something in a functional programming or Elm, for instance. You just think about your model. Like you just want the data. Don't care about anything else. You specify the data. You can, as you saw on my type slide where we model a card deck, we are trying to model a player. We could have called that a player or something like that. It has a title, it has a state, and it has a track. What is tracks? It's a list of track, and so on. And what is a track? It's something that has an ID, name, and artist. This is just a mock data. And the next thing you think about is like, what can happen? What goes on in my app? Well, nothing can happen. That's one thing. That's a no op. The other thing that can happen is we can press next and previous, and we can pause, and we can play the first. Like that's an action if there's nothing selected and you press play, or you just press one of the other keys. So this shows for me at least the power of a union type. I really, really love that I can define something so simple. Everyone can read this also from the other piece of paper. Like even if you have at your work, if you have a domain expert, it's really simple to model the domain that he wants, just sitting with him or next to the person and just typing it down. And he can quickly discover errors like, have I done something wrong? You're missing this, or you should also be able to model that. And then you define like an update. So functional programs, we kind of have this, like we have our model and we seed it with data, and then we put it in the behavior that we have defined, and then we render everything. Like we don't care about like small individual tweaks. We just write this declaratively. So we define this, we define how everything should function, and then we run it, and then like the update function actually specifies a function that updates the world on every action, if that makes sense. So we saw what actions we have. We defined what should happen whenever a given action occurs. So you can see that our update takes an action and it takes our world, the model, and returns a model. It returns a new world. And then I defined like what should go on. If in the case of action, so we just pattern match. It's quite simple to read actually. In the case of nothing, we just return the same model. Like nothing changed. It's the same. Everyone's happy. We don't waste any effort because nothing is recomputed. So another thing that can happen is the next action happens. And this is Elm's extensible record syntax. And I really adore this. It's quite simple. So it's telling like we have the object model. It defines the entire JavaScript object, if you will. And it has the key current track. And I want to update current track with this thing. It's just defined a function that finds the next track according to what we have. And you just do this for everything. Like you get this equational reasoning. So you just sit down, you think, okay, what should happen when I press this? Pretty isolated. How I get my world, how should the world look after that? And you just define that for each. I have some helpers. And then like we get to layout and view, and this is where, if you know and love React, this is where you really get the declarative power from doing that. Like you just describe the view, you pass the data in, like always parameterize everything. Like don't always give the data, always give the actions as well. Like most object-oriented programmers, they know this. Like we define, or you will define a method, and you will pass the data in and perform some behavior. But there's no one saying that you can't also define the action that you pass into the method. I don't have an example of that right now, but for instance, it could be like, I don't have a good example of that right now. I might have another slide though. So for instance, this is like, I'm just describing something layout, and it's super declarative. Like, okay, this is a 2-column layout. It's just taking some HTML, some other HTML, and then return some HTML. So now I have this function that I can combine
in my view building something bigger. And then I define my view, like how should the world look on each update as well. So it takes a column and a view player. This is this is how I defined the player on the left. And it gets the model because it needs to get the data that it's working on. So it's just described. So whenever I get a world, I look like this. And the same with the track list. And this is my page, right? You can see this in different places. You don't even have to build something dynamic to see the power of the virtual DOM or coding like this. Like there's nothing saying on the back end, like why are we using template language? Like I don't understand why we couple our data with a templating language. For me, it's wasteful. I spend so much time pulling the data out, defining some method that returns the HTML that I want. And when I decouple the presentation from the data, it's super easy for me to change the view without touching the data and adding data. A good example of this could be a menu, right? We have a side menu. It has 5 items. I decouple the view and the data. I need and those items defines links, like some data type that is a link. I just add a new data type to that list, and then I just get the another button on my view. And it's actually, if you looked at, you should go in and look at Gary's code. So you see when he creates a to-do, it pushes into a data model, and it just reflects on the view immediately after because of this declarative array. An interesting thing about this is like the only functional reactive programming related to this, like Elm is based on FRP, but it also gets all these values and benefits from being a purely functional language. So the only FRP part is this down here, and it's the same thing. Like in FRP, we have something. It's called a signal, and the signal represents this value changing over time. And then you define all your signals, like what can happen. I get keyboard inputs. I turn them into one of my actions, and I subscribe to updates. The updates is like the views, they get they get a channel, and then you can pass in actions whenever it's clicked. So I get like 2 streams. I merge them into one, and then I fold the world over that. So anyone like in JavaScript, you're familiar with reduce, or in Ruby, inject, or fold, or like it has all kinds of different names. In functional programming language, it's often called fold L and fold R. Fold P actually stands for past, so fold the past. So it's like our entire history of what's going on. And then the signal, that was the 2 different types we saw in RxJS, that it can have a value at the beginning or it can't have a value. So this has to have a value from the start or the get-go, and it's just a no-up. Like it doesn't do anything. So I'm running, this is one of Evan's demos. Mine is a bit small down at the bottom. You can see it's in the debugger mode because we have this, like he can replay state, and we can change time. So you can see this is Mario going back and forth in time. It has been done multiple times. But another interesting thing about this is like we can change behavior. Like we have the data now. Now we can go in and change the behavior because they're decoupled. And it's quite a puny jump, and we expect it to be Super Mario, so we should beef him up. So now you can see the same program with this, like the jump modified. It's kind of a nice gimmick, and I think Jexter, he will turn in his grave from seeing this, but still nice. Okay, so feel like at any point feel free to ask questions if you want to know some more about the code. The original title of the talk was this stuff. I made a quick summary of it, so I can go over that as well if you're interested. Talking about like Elm, that's first order.
the stuff that Garrick taught about was asynchronous data flow. So like there was a question, why would you go with Bacon over RxJS? Like it depends. It depends on the properties that you're going for, right? That's different strengths and different weaknesses of the different choices that you make. So, for instance, like these are the values that Evan goes for, and he feels like they help you make your apps. Like by having these constraints, they help you as a developer building simple programs and correct maintainable programs because you can only do it in this way, for instance. Higher order FRP is defining signal of signals. So, and there are some problems with that, like what should happen with a signal that's not active? Should that keep counting behind the scenes or not? And that can translate into some pretty bad space leaks, where your program crashed because it used too much memory. And the last one, errorized FRP. Like I don't want to go into asynchronous data flow because Gary did a good job of that. But errorized FRP is a different kind. It can be done in Elm as well as a library. It's a specific data type. It's called automaton. So it's automaton of A to A, and you can have multiple automatons. And you can look at one automaton as a signal, and then you can switch around them. And each automaton keeps its own score. So this automaton is active. It contains a click counter. You add some clicks. You change another one. It's also a click counter, but it starts from 0 because we haven't touched that yet. Yeah. Okay. So, like, I want to just come into a conclusion. So, there's also something called lenses or cursors or prisms. Immutable.js, if you have seen that, they had cursors in there at some point, but they pulled them out. It's a way of peeking into a data structure. So it's another way to construct applications. So you have this very complex data structure, and you don't want the small parts of your view to know everything about the entire data structure. So you pass in lenses. So like you can only look at this data structure, and that view locally can update the data structure that propagates through the entire thing. So that's one way to look at it. And Elm has actually, Evan has also commented on this. Like he feels he can add it to Elm, for instance, but you don't know if it's a win yet. So that's some area where he feels that more research needs to go into. I mentioned this CSP as well. It's really, really interesting. I don't know that much about it, so if anybody are into that or developing a CSP, please come to me and tell me about it, so we can figure out how they differ. I figured out there's something really, really close to FRP called self-adjusting computations. They're kind of similar, but they are reflecting somewhere. And yesterday evening, I figured out like there's a lot of different kinds of ways to look into FRP. But apparently, there's been some kind of breakthrough where they can use linear temporary logic to fix a lot of the issues that are with FRP. So it's going to be even better, where you can have a lot of really, really nice guarantees about your program. And there's a paper about it. Let's see where I put that. So this one. And I have not figured out what it's about yet. So, but I will go through that. It will probably be a while. But it's interesting, right? There's a lot of stuff going on. Like, don't be happy with status quo. I really, really believe that all of these techniques, all this research from academia, we should use it. We should pay more attention to what they're doing, what they're actually trying to accomplish. I think a big problem is we don't know what they're trying to accomplish. If we did that, we would actually use their work, right? Knowing that making user interfaces are a concurrent process means that you can try all kinds of crazy stuff out, right? You can try to model the user interface in the actor model or something like that. So go out there, find something new, and see if we can make the world better.
Thank
Yeah, they're actually that's a quite large topic going into another performance aspect of it. Original designs of FRP proposed a pull-based model, which caused some issue with the performance, and in Elm it's push-based, so it's pushing events. You can look at it as pushing events. So you have this, like you're kind of going for a main channel, and then you build smaller channels, and then you combine them into this main channel, which has some values that you react on each step.
Can you make your own signals? Or is that the right question? Because you can have something like custom events. Like if I have a collision between two actors,
but you
define a signal for that. Is that possible?
So, for instance, like, let's see. So this is a signal that gives you integers whenever something happens, right? So I'm not sure. Like I'm guessing you are asking. Like I would define a data structure, and then I would define a signal of that data structure. So that could be whatever, right? So whenever this happens, you got an whatever. What is whatever? I don't know. That depends on what you have defined it. Oh, you can see in the player. So we have this channel, and if I was if I wasn't in a rush when I made this, you can see I have these. These can be abstracted this way as something like heaven. So signal sent takes a channel, and then it pushes in a value into that. So you can see like the previous button fires a previous action, and so you have to have that couple. Evan recently, and not looked too much into that as well, he created something called local channels, where you can nest this stuff, right? So you can define something, and each layer should only know about the one above you. So the top level can push down local channels, and they react to that, and then still on the top level it sees everything. But I've not looked too much into that. Yep.
I don't know a lot about Elm and how's the sort of rendering. I'm assuming all this code you're showing is running the server. This is not client-side code, right? It's not.
This is actually client-side code. So he went out when he built this. He was aiming for client-side code. It's just that when I saw this when I saw the isomorphic applications, I could see like there's a potential amount of value in doing this stuff. And in the Haskell community, there's tons of stuff going on. There's multiple tries of creating something called like Haskell React or some subset of Haskell combined with React. But I don't believe that the correct combination is something with React per se. I believe the right combination is something with the virtual DOM. In recent years, for me at least, like the virtual DOM is the abstraction that has proven the most power for me. Like, it's absolutely amazing what I can do, and I can see where we can go with that. So there's a lot of interesting going on, especially on the server side here. And also, I don't know if I have that open though. Okay, I just wanted to show I wrote down some more of the views, like this style, right? You define a page. What is a page? A page is something that takes a navigation. It takes some content. It takes a footer. That's a definition. And then you go out like, okay, what does navigation mean? Then you define that. What does this mean? Then you define that. It's super easy to work with, and I see no reason why we don't write all our views like that. Even today, like we use Ruby on Rails, and my Haml views are looking like really strange because I pull out all the data, and then I define some function that creates the view, and it gives me so many nice properties, right? I started something called a component guide, where I develop in isolation. So when the business tell me we need something like that, I'm just okay. I go to the style guide or the component guide, and I start to develop isolated. Like I built this thing. Okay, I have some data. Cool, I have this data now. Then I try to define what should that data look like. And I can look at this super isolated, like it works. So now I can build this feature isolated, it works, and then I take it out, and then I plug it in somewhere in our system. And the nice thing about this is that our business people, they can always go into this component guide as well. look at our features. They can suggest stuff like, wouldn't it be nice if this could do that, or look like this? Well, we can add that, or we can talk about it. And the most important thing about this component thing is that it should run against real code, like real production code. So if it breaks in isolation, then I know it's broken. And like, so if someone tells me, hey, we have a bug here, I don't try to figure it out like that. I can just, for instance, a browser-related bug. I just open my component guide in that browser and say, yeah, you're right, it does not behave as we expected. And this, like, oh, sorry, yeah.
Just wanted to ask about CSS. Actually, does Elm do anything about CSS?
Originally, it was created where he didn't want to touch HTML and CSS at all, because he saw too many problems with it. But after we got like the virtual DOM, he kind of went in and built it like that. So now you can use CSS as well. But another cool property, like, let's see. Okay, oh shit, let's find that though. Okay, so this is an example, like, what is a page? A page is something like this, that class. But you can also define styles in here if you want. And I don't know if any one of you guys were here at the December meetup, where one of the Facebook developers there. He has this interesting notion of, I didn't know if you talked about that though, like using JavaScript to make CSS as well. It's actually quite interesting. Like you have this combined thing where you can speak about what you do, and it's easier to make animations when you can build some styling that triggers CSS animation, where you get the values from the world, so you get the correct value. It's really helpful. Yeah.
It's out of subject, but the WhatsApp team just released a web client, and it's fully made on React. So have a look. It's interestingly good.
Any other questions? Else? Oh yeah.
Can you model nested states easily with that?
Yeah. So the interesting part about it, Evan is doing tons of research right now on how to architecture apps. Like that's why he has opinions about the lenses and the focus stuff. And I don't have the let's see, architecture. So I just want to show some meta code from him here. So you can build a model that's nested. Let's zoom in on this. All right, so these are separate entities. So this is a module defining a search bar, and then you get the action from that search bar. And then it just keeps on nesting them in a hierarchical way. And so his approach is that only two layers needs to know about each other. He made maybe this makes more sense. Oh, I don't have, let's see. He made this model like of how we can do, and how, for instance, how to build a Spotify app, where he showed like, okay, this model, this model, this model, and then the main app just grabs that. It doesn't care, and then each component can have sub-components as well. This was not what I was looking for though, but.
Thank you very much. Really interesting. Thank you very much. Okay, so let's. I don't know if there's any pizza left, but it's probably more days to help yourself. Save a bit of chat. Red Badger's hiring as well. Everyone's hiring. If you want to be a software engineer at Red Badger, any badgers, hold your hands up so that you know to go and talk to somebody with a hand up. And we'll see you next month at Facebook. So it's opposite Warren Street Station. We'll give you all the details and everything. I'll put the links, and also the competition thing we'll put that as well. Thank you very much. Enjoy.